Alright guys, let's pick up where we left off in class. We'll ignore this a little bit. We're going to be talking about maximums and minimums. Okay? These are easy. Maximum, top of the graph. Minimum, bottom of the graph. These are going to be points. Again, pause the video when you need to so you can jot down your notes. So, if I were to draw this in my notes, rough sketch, point right here is going to be 0, 1. Guess what? This is like a mountain. Top of the mountain is right there at the 0, 1. So this has a max of 0, 1. Maximum point. Minimum, this is like a valley. This will be the lowest point. Again, if you're drawing this in your notes, you really just need to focus on that point, which is 0, -2. So being that that's the lowest point, we're going to say the minimum is, don't know what's going on right there. Let's delete that. Minimum is going to be 0, -2. Okay, these are really, really easy. How high is the graph? How low is the graph? Max, min, and you use coordinate points to answer the question. So again, pause the video so you can jot this down. If so, if not, I'm moving good forward. So looking at this graph, again, if you're to jot this in your notes, I will simply say this point to this point, and I would write those as 3, 1. And this one would be -2, -2. So if you were to ask me, or if you were to ask what the max is, obviously you would say 3, 1, because that's the highest. The minimum, lowest would be -2, -2. Now, see this graph? Again, putting it in your notes, I'll just draw that. This has none. It doesn't have a maximum, it doesn't have a minimum, because these arrows means go on forever. It's going on forever in infinity direction, negative infinity direction, so it has no max and it has no min. This one is a tricky one, but listen to me. The fact that it goes on forever and ever, it too is going to be none. No max or no min. Because technically this goes on forever and ever, and it keeps constantly getting lower and lower. And this one keeps getting higher and higher with no limits, going straight to infinity. This is going to negative infinity. I mean, there's no max or min, okay? When these graphs go on forever like that, then there's no max. Similar to the examples up here, these go down forever and ever, but I only answered this as a maximum because it only has a maximum. This one's flipped upside down. It has a minimum, but these arrows go on forever, so there's no maximum. Okay, obviously this line has endpoints, so it does have a max and a min. This has arrows, it has none. And this graph, even though it's curved, that's why I said it's tricky, it's still none. So again, pause the video where you need to, rewind where you need to. I'm moving on. This should be in that packet you had the other day. So dig it out so you can start taking notes. Pause the video if you need to. Yes, I'm talking to you. Dig it out. All right. So now that you got it out, we're going to say blank, a line that a graph gets blank closer and closer to, but never blanks or touches. That's right. Asymptote. A line that a graph gets closer and closer to, but never crosses or touches. Blank, the point at which the line intersects the blank at blank. So this is going to be x-axis. The point at which the line intersects the... Oh, I'm being dumb. That's in the wrong spot. I was reading that and I'm like, no, that doesn't sound right. X-intercept. Aha! Intersects the X axis. Let me put an X right there. X axis at, and remember this was that coordinate point. We're going to put number here and 0 there. So this obviously must be the y-intercept. Y-axis. And this will be 0 with a number at the end of it. Shoo! Looking good. Decreasing, increasing, always move left to right. If your finger is going up, the graph is increasing. We talked about this in class. Finger is going down, the graph is decreasing. And if the finger doesn't go up or down, the graph is constant. Let's see what's next. Blank, the blank point of a function. This is max, highest, min, lowest. Again, pause the video where you need to, but you should have notes on all of these already. Because I'm moving on. I mean, if y'all could look at the time down here, it's 1 o'clock in the morning, and I'm trying to get this done for you so you can be smarter. Okay? So, domain, again, when it goes to the edges, it's just going to be all real numbers. And again, go ahead and pause the video, try to do it yourself, and then, move on. Range, you got this asymptote down here, so we're going to say -4 to infinity. It's the parentheses, not a bracket. Intercepts, do we have any? Yep, we got 2 in one spot, 0, 0. The y and the x intercepts in the same spot. Is it increasing? Sure is. Do we have a max? Not necessarily, because it goes up forever. Minimum, same thing. It's getting lower forever. Well, it's always constantly getting lower for forever. So that's no max and no min. So I put NA, not applicable. Asymptote, we just discussed it to be at -4. Yep, we should be able to fly through that easy. Okay? Again, pause. Uh-oh, what just happened? So pause the video and try these out, and then start her back up to see the answer. All right, we're back. Again, most of these are going to be all real numbers for domain. Range, how low did you go? Negative infinity, how high did you get? 0. Again, parentheses for those. X-intercept, technically it's not going to cross the x-intercept in A. Y-intercept, I'm going to argue it's a -1. So, 0, -1. Increasing, decreasing, guys, this bad boy is going down. She's a decreasing. Max and min, again, we just discussed this going down and up forever, so in A. Asymptote, well, we just discussed that to be at the 0. Shoo, we're getting better at this. Domain, again, all real numbers. You should have paused the video. Let's check it out. To work it out, I mean. Not check it out. Work it out. Range, again, how low does it go? Guys, I'm going to argue it's at the 3. Y equals 3. So our range is going to be 3, because that's how low it can go, to infinity. X-intercept, again, it's not touching the x-axis, so in A. Y-intercept, I'll argue it's at 4, so 0, 4. Okay, again, we should be flying through this. Looking at the graph, she's a going downhill, she's a decreasing. Again, there's no endpoints. It goes on up forever and it goes down forever. So in A for this guy, Asymptote, we just discussed it to be 3. Ooh, looking good. Pendulum swings 90% of its height on each swing and starts with a height of 80. Height of the pendulum in centimeters is y is recorded to x number of swings. Write an equation to determine the key features of this function. Guys, it's telling you the pendulum is swinging 90% of its swing. I know you would want to use your formulas to try to figure out, you probably would want to use that P minus, R, et cetera. But they pretty much already giving you what that rate is going to be. If it's swinging 90% of its swing, then it's like it's, you're depreciating it or decreasing it by 10%. Because then you go 1 minus the 10 cents, remember, to get that 90 cents of that swing. So in hindsight, start off with 80. It is swinging 90% of its original swing. And we put an X up top. Okay. And I did that based on how it was read. Also, you got to move the decimal over. Again, changing percent to decimal should be a no-brainer. So, we got our equation. Domain, on the other hand, well, it looks like we start off at 0 and we're counting swings. So I would argue you would want to write this as 0, 1, 2, 3, dot, dot, dot. And that just shows you're stepping 1 up every time. Obviously, they start jumping around down here, but I'm going to argue domain is that. Range, you can get away with the same thing. 80. Well, you know what? They did stop it. I didn't even see the bottom of the table. So, now I have to be extra. Because I remember giving y'all notes where we list them all, least to greatest. So, have to be extra now. We're going to put 5, 10, 20, 40, 40, 60, and 80. And just as extra for the range, 0.02, least to greatest, 0.14, and you should have plenty of space to write this. Because if I can write it, you can write it. And I might be sticking my foot in my mouth because I'm running out of space already. Oh, I don't know, guys. She ain't looking good. I'm gonna list them up here. Yeah. 58.32, 64.8, 72.8. Shoo. I'm finishing off my bracket. That's me finishing my bracket off. Anyway, I tried fitting it all on one line. Intercepts. Got a swing. It's decreasing. The fact that this is not 0, I would argue we only have that y-intercept. So I'm just going to label this. We have a y-intercept. It's going to be 0.80. Starting point, remember? Max, I will also argue this because your graph is going to look like this. Okay? It's not touching the x-axis. It is touching the y-axis up here at that 0.80. So I'm going to argue we have a max at 0.80. This is a point because I stopped it according to the graph. Increasing, decreasing, it's obviously going down, so it's decreasing. Discrete or continuous, we're counting swings. So what I really need to do is put dots through here, don't I? Because, we want to make sure we're right. So I would argue there's dots through here to represent number of swings, to make it discrete. All right, I'm back. Let's check recording. Recording looking good. Alright, let's keep going. Characteristics. Can't really remember if I gave you this or not. Guess we'll just work through it. Domain, again. All real solutions. Range, how low can you go? Y equals -2. So, -2, parentheses, to infinity. Asymptote, y equals -2. X-intercept would be right here. So -2, 0. Y-intercept is right there. I'm just going to argue a half for the sake of time, since now it's 1:39 a.m. in the morning. So 0, -1.5. See what else we got under here. It is decreasing. This is decreasing. Y-intercept is 0, -tree. X-intercept, -1, 0. Asymptote looks like it's going to be a 1 for this one. So y equals 1. Range is -infinity because you went low. And how high do you get? 1. And domain, all real solutions. I'll write that better. All real solutions. Y equals 1. Again, pause the video, try this out on your own, and then hit play, and we'll see if we get the same thing. Alright, here we go. Domain, all real solutions. Range, how low did you go? -4 to infinity. Asymptote, y equals -4. X-intercept, I would argue it's -3, 0. Y-intercept, we'll just argue 3.5, so 0, -3.5. And it is decreasing. Over here, I would argue that it's decreasing. Y-intercept is going to be 0, -tree. X-intercept, we're going to say there is none. Asymptote's -1. So -infinity to -1. And domain again, all real solutions. Boy, I tell you what, I know I'm great at this. Y'all better be getting better at this too. Pause the video and see if you can knock it out. Alright, here we go. All real solutions again. Range. -3 is the asymptote. So it's going to be y equals -tree. Oh my gosh, I put that in the wrong spot. Put that right there. Range is how low you go, which is -3. How high do you get? Infinity. X-intercept. I really want to argue 0.75 for that. So I'm going to put 0.75. 1.75, 0. Might even be a 0.6 to be honest. Y-intercept, we're going to argue 2, so 0, -2. And we are increasing. This one is increasing. No X-intercepts. Y is going to be 5, so 0, 5. Asymptote, y equals 2. Not even going to draw the dotted line because we're getting better at this. To infinity, and domain, again, all real solutions. You had 20 shirts in your closet before you went shopping. Every week you went to the mall and bought 3 times as many new shirts. Write an equation for the exponential equation and determine if the key features of this function. So it looks like we're times 3 every time. And that's our pattern. So our equation is going to be our starting point, which is 20, times 3x every 3 times. Every 3 times. Every 3 times. So, what's that? I would argue number of visits we're counting, so I'm going to argue it's discrete. Domain, since we're basing it off this table, we'll say 0, 1, 2, 3, 4, curly brackets. I'll argue there's no x-intercepts, because if you were to look at this, if you start at 0, the number of shirts is at 20, and it just goes up from there. It doesn't touch the x-axis. Yes, I heard you. Should be dotted, or with points. There, fixed it. Not dashes, but like points. Anyway, so no x-intercept. Y-intercept, on the other hand, is going to be 0, 20. Oh, jeez. Max. We're gonna say that in this situation, based on the table, our max is going to be at 4, 16, 20 would be our max. Minimum, again, basing this off the table, but it makes me wonder, does this table keep going? Write an equation for the exponential equation and determine the key features of this function. Every week, went to the mall, bought 3 times as many shirts. Guys, I mean, honestly, realistically, he shouldn't be buying this many shirts. This is insane. And if we just kept going, this number would keep growing. So, man, this is such a subjective question. Obviously, the minimum is 0, 20. Maximum, based on the table, is this. If we were to put that arrow on this graph right here, then we wouldn't have a maximum because it just keeps going. Again, really hard to, give an answer for this one, in my opinion. Because let's face it, there's no way we're going to buy that many shirts. In fact, it almost gets unrealistic when you get up to the 60. Never minding all that, this is increasing. And the range, since I already told you should be listing it, we're going to put 20, 60, 180, 540, and 1,620. Okay. Now, granted, this would have been a great discussion to have in the class, but, whatevs. Rate of change. You also hear it being called the rock. So do you smell what the rock is cooking? Rate of change is always going to be the slope. As you remember, slope is rise over run. The formula for slope is y2 minus y1 over x2 minus x1. So again, pause the video as needed. But here's your example. It says find the rock at 1, 3. If I were you, I would go 1, 12 and 3, 16. Because I'm telling you, these are x values. And you need to find their complementary y values. Now that you have that, you can plug it into this formula and then get your answers. Because remember, this is x1, this is x2. So 16 minus 12 over 3 minus 1. And we get 4 over 2, which is 2. So the rock between those is 2. Let's keep going. Again, pause the video so you can jot it down. Now again, this is your x1, x2. So let's find the coordinates for y1. 5, just plug it in. Let's see what we get. I'm using my calculator. Plug it in as I see it. I got 490. Again, let's do x2, y2. Plug these values in. We get 13,126. This is a big comma, separate the x and the y. Now plug that into the formula. That was on the last screen. So we're going to go 13,126 minus 490 all over 8 minus 5. And I'm just going to use my calculator for this. My calculator says we get 1,212. Don't you just love when the calculator does all the work for you? Alright, moving on. Don't forget to jot down this. Plug in the two x's to get the y's. Then do the slope formula. I literally just did that. Jot these notes down. Rewind it. Do what you got to. Get this learned. Sometimes you'll see graphs. For rock 2, remember these are x's. If I were you, I'd get the points. x1, y1, 0. If you go to the 0, oh, right there is 1, 2. Let's get the other one. X2 is 2. Go over to the 2. Go up. 1, 2, 3, 4, 5. It's 5. Use your slope formula. I get 3 over 2. Guys, I want you to notice something. 1, 2, 3. 1, 2. Rise over run. You can count it out. Either count rise over run on the graph or use the slope formula. Alright. Detailed pollard. I'm running out of gas, guys. Let me look at the time. It's 1:51. 1:52. Just changed to 1:52, and I gotta go to bed because I got a conference in 4 hours. Or 5 hours, or 6 hours. I don't know. I just need to go to bed. Ugh. What time is it? How much time do we put on this? We got 30 minutes. Alright, guys. I'm going to continue this later.